All right, we're going to keep on with our lesson on the hydrosphere. So we're coming into the end of the hydrosphere and we're going to talk about oceans. So, of course, where's most of the water at on this earth? Yep, oceans. 71% of the earth is covered by water. And 97% of that is oceans. We can't drink no doggone salt water. All the oceans and seas are actually one continuous body of water. Now, who are the people who study oceans? Oceanographers. But oceans are very important. Oceans are very important because oceans have living things. Some of y'all like fish, crab legs, and shrimp. Oceans affect all living things, those from far from shore and those inshore. Oceans also provide a place and a habitat for many animals. Now, how were the oceans formed? You know, there have been so many different ways at how the oceans were formed, but when Earth was still a young planet, they were trying to say it was so many volcanoes. As they erupted, ash and gases were released from the Earth, and one of the gases was water vapor. Now, what they're trying to say is over 1 million of years, the water vapor cooled down enough to condense, right? That's the water cycle. Water vapor and then condensation. Then all of a sudden, it began to rain from the clouds called precipitation. But eventually, much of the land was covered by water that was formed. Then the water just never went away and it kept repeating a cycle. But we have 4 oceans. What are our oceans' names? Yes, Atlantic, Pacific, Indian, and Arctic. What is the largest ocean? I'll give you a hint. It starts with a P. It's on your screen too. Pacific Ocean. The area and the volume of the Pacific is greater than Atlantic and the Indian combined. Okay, so the Pacific Ocean is huge. So, what is the difference between an ocean and seas? Well, a sea is one of the largest bodies of salt water, less than an ocean. So it's not as big as an ocean, but it's a huge body of water. And those are found on the Earth's surfaces. So, for instance, we have the Mediterranean Sea, the Arctic, the Black Sea, and those are actually really just part of the Atlantic Ocean. It's just different areas. And it's like, again, not as big as the ocean, but a portion of water that's there. So, what's inside the ocean water though? Like, what's so important about this ocean water? Well, it's a mixture of gases, solids, dissolved in pure water. You obviously know what's inside ocean water. Salt, and it tastes disgusting. Oceanographers believe that oceans contain all the natural elements. Well, honestly, and it says 85 to 90 have been found in the ocean. Now, what do? When we get oil, where do we go? To the ocean. When we get natural gas, we go where? To the ocean. When we try to find the best sources for the earth, pearls and everything, where do we go? The ocean. So the ocean it's got our resources there. So ocean water is 96% pure water. All right, so chlorine and sodium. These are your element names. Make up the next largest concentration of elements. Sodium chloride is table salt. Sodium chloride is table salt. This right here, that's sodium chloride. That's the little salt you be eating on when you put on your fries. So, because we know that the ocean, it has salt in it, what do we call the salt levels? We called it salinity. Salinity describes the amount of dissolved salt in the ocean. Salinity is expressed parts per thousand. So again, this is kind of a little pie graph that can kind of break it down just a little bit for you. So we realized that the ocean has salt, and it did say that it was abundant, but we also said it was some type of gases. But what gases is obviously in ocean water? I mean, we know water is H2O, so we were seeing hydrogen and oxygen. But what else is in there? Well, it actually has nitrogen. Why would it have nitrogen? Well, it has animals, right? And remember, the nitrogen cycle happens when an animal, I'm just going to draw a little stick figure, eats grass, and they poop in the grass, and then it comes back, right? And then the grass comes really green and big, and they eat it again. Well, obviously there's animals in the water, and every animal has to poop, so the nitrogen levels are high there. Now, what about carbon dioxide? Well, are not there plants under the water? And they release what back in the atmosphere? Carbon dioxide, as well as they take in carbon dioxide from what? The animals that are under there, right? So they need carbon dioxide for the plants to live, and then of course oxygen because it's animals. So the amounts of these elements are vary with the depth. They are more abundant at the ocean surface because sunlight can happen, and that's what photosynthesis happens. Photosynthesis. Remember, it needs carbon dioxide and oxygen to take place. So a lot of times it's going to be where the sun can hit. So the darker it is, the less that's going to happen. So the temperature though, like I love going to the beach. One thing I hate is I don't care if it's 100 degrees outside. Sometimes when you get it, that water is cold. Warm water holds less dissolved gas than cold water. When ocean water is cold, like polar regions, it sinks and carries oxygen-rich water to the ocean depths. So the colder it is, oxygen is going deeper. As a result, fish and other animals can live in the deep parts of the ocean because there's so much pressure. The deeper you get down in the water, it's a higher level of pressure. So it's kind of hard to breathe. But because the water actually kind of stays cold in the ocean, it allows them to breathe regardless of the pressure. Now for us, no. Now, what's obviously in the water? We talked about this before, but it's what? Waves. So we talk about waves but being sound waves, but obviously water has waves too. And it's a rhythmic movement that carries energy through the water. Waves are caused by high winds blowing on top of the water. So as the wind blows, the water goes. Now, what does the waves eventually bring, though? Well, they bring in something we know as tides, but we talked about tides before. So this is a review and reflect about our tides. And so remember, those change throughout the day as well as the moon. A tide is a giant wave that can be thousands of kilometers long, but only 1 to 2 meters high in the open ocean. Tides, remember, came from the gravitational attraction from Earth, Moon, and Earth and the sun. Remember, there was different tidal waves that we had. We talked about this before, so this is just a review. So remember high tides with where the path of the moon is and the sun and the earth. So again, tides are created by the gravitational attraction of the earth and the moon, as well as the earth and the sun. So what is their attraction? Biggest key, gravitational, gravity. Now, how does the water move? So we understand tides again come from the gravitational attraction. We understand that they said that it came here from water vapor that eventually condensed and became precipitation and never left. We know that at least 92%, 97% is pretty much purified water. But now how does the water move? Like it comes right back. Well, the upward moving of cold water from the ocean is called upwelling. Well, key word here is up, and this word is upward. So upwelling is upward. So as you see here, the cold water goes here, and then surface water moves, and then it's moved by the surface winds. So upwelling brings tiny organisms and minerals and nutrients from deeper layers of the water. Without upwelling the surface, the ocean would be nutrient deficient. What happens is the nutrients that are here can come up from the bottom and go back around. Now there's times that seaweed comes. Seaweed doesn't float on the top of the water, does it? No. It floats, it's at the bottom, it's on rocks. So as the water is coming up, it brings up seaweed, it brings up some crabs, it brings up different fishes and different algae, but this brings nutrients to the other fishes and stuff that live here, and then it just keeps on recycling itself. Now you have to know the difference between the El Nino and El Nino. So El Nino is abnormal climate that happens every 2 to 7 years in the Pacific Ocean. This causes the change in wind, currents, and patterns of the weather. El Nino is abnormal, happens every 2 to 7 years in the Pacific Ocean that causes change in the wind, the currents, and patterns of the weather. What happens though, he interrupts the upwelling. So what does El Nino do? He's abnormal, comes 2 to 7 years, and he interrupts the pattern of upwelling. Remember, he changes the wind, the currents, and the weather. This happens though without the nutrients provided upwelling. What happens? Fish can't do what? Get food. And so what's eventually going to happen to some of them fish? They're going to die. Or some fish are going to come out from hiding, like sharks, and they come from a deeper place to the shore to find food because something was switched. So fish and other organisms die because weather patterns are disturbed. So then we have these crazy weather, the bipolar weather that we be having. So the ocean floor. Now, please remember that, of course, the ocean floor has mountains, it has canyons, it has just what you see here on above the ocean. And those just come again with erosion, plate tectonics. Earthquakes happen a lot. A lot of times volcanoes, again, remember, happens on in the ocean. There's a lot of volcanic arcs. Some earthquakes take place near the ocean. The rocks are different, and remember, the crust is very thin. So oceanic crust is a lot thinner than continental crust. Think about it. Put a cracker in water. It's kind of mushy and crumble up, right? But you put like a rock in water, it's not going to mush up. That's kind of how you do it. The cracker eventually will float and then sink and mush up. A rock doesn't. So that's kind of to identify continental versus the oceanic. So the continental shelf is gradually sloping end of the continent that extends under the ocean. Okay, so it extends under, not above, but under. The ocean covering the continental shelf can be as deep as 350. So this is where, again, I told you our ocean is found for our biggest things. So minerals, oils, natural gases, this is where it's found in the continental shelf that happens, again, under the ocean. So at the edge of the continental shelf, it kind of goes to 4 to 5 kilometers. The continental slope, though, extends from the outer edge of the continental shelf down to the oceanital floor. So again, a slope. Okay, from the outer, and again, down to the ocean floor. So this curve, that's your slope. Here's the idea again. So here's the ocean, the water. Here's the slope. Here's the bottom of the ocean floor. Look at how the volcano islands happen, the abyssal plains. We have little mountains inside there. So what is an abyssal plain? Well, it's large, flat areas on the ocean floor called abyssal plains. They are larger in the Atlantic and Indian, so there's not a lot in the Pacific Ocean. Okay, the Pacific Ocean has large cracks that trap sediments, resulting in smaller abyssal plains. Okay. They are close to the continent, and they're made of mud, sand, and silt. Farther out the abyssal plains, some of them contain the remains of tiny organisms that form ooze. Ew. Where ocean life is not abundant, the floor of the ocean is covered with red clay. So if it's no life living there, it's covered in clay. Now, what is a seamount? What's a guyot? Well, a seamount is underwater volcano mountains that rise over 100 meters above the ocean floor. Most are found in the Pacific Ocean. So the Pacific Ocean has a lot. It doesn't really have abyssal plains, but it does have seamounts. Remember, and it's the largest ocean. Some seamounts reach above the surface of the water to form islands like Azores, Atlantic, and Hawaiian Islands. Of course, there's a lot of volcano arcs. Now, guyots is the flat top seamounts. Then we also have a trench. So trenches, though, is kind of like, uh, as you see here, like a mini, like a valley. Okay, they're the deepest part of the ocean, found along the edge of the ocean floor. The Mariana Trench in the Pacific Ocean contains the deepest one, and that's called the Challenger Deep. And look how tall Mount Everest is, one of the tallest mountains, but that's how deep that trench is. It's even deeper than that. You would hate, some of y'all can't even go 5 feet underwater, so imagine going 11,000 meters. Mid-ocean ridges, we talked about those before. So with the mid-ocean ridges there, this is the area in the ocean basin where the new ocean floor is formed. So remember when we talked about the plate tectonics and how they spread and come together? Well, this is it. So this is almost like a continuous mountain belt that extends. All right. And remember, how did we know that Pangea existed? These right here, because the same mountain belts actually are here that are overseas. So it lets us know that we eventually was connected before. And as again, you can find this through Atlantic Ocean, Africa, and the Indian Ocean, and across the Pacific. And of course, it is called the Mid-Atlantic Ridge. In the Pacific, it's called the Pacific Antarctica Ridge because we have the same mountain belt and everything. So again, ocean life. There's different things inside the ocean. We have plant and animal life. Remember, the one factor is the amount of sunlight that hits. If it hits good amount of sunlight hit, then the photosynthesis can take place. Another factor is the temperature. But then it's also water pressure. So sunlight, temp, water pressure. So sunlight, temp, water pressure. Okay. So there's different types of groups. And these are just main ones: plankton, nekton, and benthos. Plankton float at the near surface. Y'all remember plankton from SpongeBob? Yes, he's really a plankton. Okay. Most of the plankton are very small, such as algae. These organisms drift currents or tides. Plankton is the main food for most of the larger organisms. So he was basically the little person trying to always stand up for himself because he was a little person on campus. Plankton and then jellyfish, which float on the over surface, is an example of a type of plankton. But nekton are whales, seals, dolphins, squids, octopus, barracudas, and other fish. Nekton are free-swimming organisms that feed off on plankton. Many have adaptations enable them to function at depths that have no thing. So remember, we have oops. Let me show you who. Y'all should know who this is. It's probably not going to look right now, but I apologize. Trying my best to get this for you to identify, because that's not it. But you're going to identify him. I have to draw him right here, and this is not going to be a great thing. Yes, that's Squidward. Okay. And then nekton, colored fish. You know, we have like a little Dories and our Nemos. And then benthos. We have crabs. We have lobsters. There are just a few examples again. Just a few examples. I just messed him up though. But that was being Mr. Krabs. It's kind of hard to draw with my pen, but yeah, you get the idea. These are your animals. And the starfish. This is one of my favorites. If I can, again, I'm just drawing him. Doy. All right, so starfish. All right, catch y'all later.